All right, to finish up this video, this section, let's first ask, is the following graph, is this a graph of a function? And explain your answer. Well, you may already remember the vertical line test, which we'll talk about that later, but how could you in words tell me that this is or is not a function? And just remember, here's a nice easy way. That's the origin right there. So what is f of 0? What is the value of f of 0? What's the height of the function at 0? Notice, which value do you give? This one, or this one? There are 3 different ordered pairs on this function that start with 0. Did I say function? If I did, I shouldn't have. This is definitely not a function. I could say, I'm just going to put A, B, C. One of them is negative, 2 of them are positive on the y values. But I will say this, f of 0 has, we can call it f, but it's not a function. So maybe I could use a different letter. It's a relation. F of 0, I'm going to go ahead and call it f, even though it's not a function. F of 0 has 3 values. So it can't be a function. You can't have more than one ordered pair that starts with a 0 and has different numbers for the y values. All right, let's look at these graphs and which of these are functions. Well, we won't spend too much time on this. This one is a function. There's no x value that has 2 corresponding y values. Same with this one. For example, in both of these, if you look at x equals 0, there's only one value of f of 0. In both cases, in this, it would be negative. But there's no point here on the x-axis where you can find 2 values of the functions, like above and below it. Now this one, of course, this one is not a function. The easiest way to describe it was say, just look at x equals 0. F of 0, there's one where it's positive and one where it's negative. Has 2 values. Or this f of 0, the relation is 2 different values. So function, not a function. And for the similar reason, at x equals 0, you've got the height of the function being up here, a positive number, and also a negative number. Because of that, not a function. How do you analyze a graph? Specifically, if I were to ask you to find the value of the function in a graph, given the value of x, say x equals 3. Well, it's very simple. May I not even write it down? Look at 3 on the x-axis, and then go straight up or down if necessary, and measure or count the height of the function. Height of the graph, I'll say. And if it's above the x-axis, it's positive. If it's below, it's negative. So for example, we looked over here at x equals 3. Let's say this is 2 and say that's 3. Well, the height of the function, the value of the function at x equals 3, you go to x equals 3 on the x-axis, and then just go, in this case, we go straight up. We get to this point, and whatever that y value is, maybe it's looks like it's more than 3, maybe 4. So the value of this function at x equals 3 is the height of the function. What's the height of the function here? Well, just go to the y-axis and measure where that is. So it'd be 4. And I think number 12, the last thing, we already determined this, I think. Well, maybe not explicitly. Can you identify the domain and range from a continuous functions graph? A continuous function, we'll talk more about it later. It's just a function you can draw without lifting your pencil. You can graph it. Can you identify the domain and range? In fact, you can. Let me just do a couple simple examples. I don't want to spend too much time on this right now. But let's say we've got 1, 2, 3. 1. And maybe 1, 2, 3, down 1. Let's say this is a line. A line segment. I'm not putting arrows where it goes on forever. And this is, -1, that's 1, 2, 3, and so on. What are the domain and range of this function, which I will call f? It is a function because every x value from -3 to 3 has exactly one value, one height corresponding to it. You can see that f of 0 is 0. Well, the domain is all of the possible x values. So what is the leftmost point? -3. What is the rightmost point? Rightmost x value. We're going from here all the way to here. And on the x-axis, that would be +3. And we write this like an interval. So the domain would be -3 to 3. All of the numbers from -3 to 3, all of them in between, and even including it. Sometimes on the graph, we'll put this closed circle. That means that point is actually on the graph. If I used an open circle, it would mean there's a hole in the graph there, that it does not exist at that point, but only everything strictly in between. All right, similarly, let's look at the range, only we're going to go up and down. Height, what's the lowest point on the graph? Well, the lowest point is right there, -1, and the highest point is +1. So -1 to 1. And there's a little trick I sometimes use. If you take a rectangle with only horizontal and vertical lines and take the smallest possible rectangle that will contain this graph of the function, it would look like this. It's not a very good rectangle, but you get the idea. The domain is the left endpoint, the left point to the right point of the rectangle, -3 to 3, and the range is the height, the bottom to the top, -1 up to 1. So the range is -1 to 1.